Okay guys, so let's talk about little bit more about resistors. Resistor is very taken in granted quantity. You can see resistors almost in every circuit. Remember that resistors are ubiquitous. They are present everywhere and they are taken so granted. So you see resistors in amplifiers. Resistors are used as a load in the active amplifiers. They are used as active devices. You see resistors in the RF circuits. So RF circuit stands for radio frequency circuits, where resistors are used to set the bandwidth, which is very important. Maybe you are not familiar with these terms, but I thought, okay, this let us know our students that what the resistors are used for. Resistors are used in digital circuits a lot. They are used for pull-ups and pull-down voltage levels. That's the use of the resistors. Along with this, they are used in a feedback circuits. So feedback is one of the important phenomena in the analog or electrical circuits. We will see about the feedback, maybe not in this course, maybe my upcoming courses, but this is something you should know. There are two types of feedback, positive and negative feedbacks. There is something called as feedback element. So resistors are used as a feedback elements in these circuits, which is very useful and which is very widely used in the industry. So let's take a look at the few circuits, actual circuits, where you can see the resistors are there. I have gathered few images for you guys. Okay, so here you can see this is a push-pull amplifier. So here you can see this is a push-pull amplifier, and you can see there are resistors are being used, R1, R2, R3 and R4, where these two are BJTs. This is a 3-terminal device. Maybe we are not discussing about this device in this course. So here you can see the use of resistor. Then this is how the resistors actually look. I think these are capacitors, but these are all resistors, and generally they are made up of carbon or metal films. So you can see the resistors with some color coding on it, and we will talk in a few minutes about the color coding of the resistors, how to find the resistor value. And you can see here this is a filter. It's a RC low pass filter, and you can see here their use of resistor and capacitor. So as name suggests, it's a low pass filter, so it allows the frequency at a lower frequency range. So this is the frequency range where it allows a signal, while this is a frequency range where it attenuates the signal. In next application we will talk about this block. These are the op-amps, which is called operational amplifier. If you see carefully, the op-amp has feedback element. Feedback is something, it's a resistive element which is connected from the output to the input. So the resistance R2 is connected from output to the input, as well as it has a capacitor C. We'll talk more about the capacitors maybe in my next section. So this is one example where resistors can be used in the feedback elements or in the op-amps. More technically speaking, this is actually a differentiator circuit, and we will talk maybe in my next course. I will brief you about this circuit. Now the next application is pull up or pull down resistor. Here you see the resistors are connected in the two ways. There is this output, and there is this resistor which is going from output to the ground. While in this circuit the resistor is going from the output to supply. Suppose this is a 5-volt supply, and in this case there are two switches. This is a switch 1 and this is a switch 2. So if the switch 1 is pressed, okay, if this switch is closed, the output is shorted to 5 volts. So output is going to be 5 volts always when this is closed. But what about when this is open? When this switch is open, there is no path for the output to pulled up, because this is open. So the resistor will pull this output to down. That means output will be shorted to ground. That means output will be 0 when switch 1 is open. But when switch 1 is closed, output will be directly pulled up to 5 volt, because output is shorted to 5 volts. So in this case, this resistor is called as pull down resistor, because it's pulling down the output. When in this application, the output is connected to VCC to power supply with pull up resistor, while there is a switch between the output and the ground. So when the switch is closed, so let's say switch 2 is closed, what's gonna happen is output is pulled down because it's shorted to the down. In that case output is 0. But if switch 2 is open, then output will be pulled up to 5 volts. So output is 5 volts when switch 2 is open, and in this case this is known as a pull-up resistor. So this is one of the application of the resistor. This circuit is used in almost every digital analog circuits. Pull-up and pulled-up resistors are used. They are more predominantly used in the digital circuits. So that's it about the applications of the resistors. I mean, there are many more, but due to the time constraint we will see only 5 or 6 of them. Now let's go to the next section. In this slide we are going to talk about color coding of the resistors. If you see any resistor, it always looks like this in real, and it has some color codes on over it. Color code means it has different lines of the colors. You can see there can be 4-band color code, 5-band color code, or 6-band color code, while each color code always represents something. For example, if you see this 4-band color code, it has red, green, orange, brown, 4 color codes, while these 3 color codes are grouped together, and then there is some space, and then the 4th color code is on color code band is on the other side. So it will be always like this. In 4, 5 and 6 band color code, either 3, 4 or 5 bands are grouped together, and 1 or 2 bands are grouped together to the other side. So let's talk about this 6-band color code. In 6-band color code, or 5-band or 4-band color code, when there are 3 or more than 3 bands are grouped together, then this color, that the first color on the lead side, the first color denotes the first digit. So this denotes red, that means digit 2. Second color is purple, that means digit 7. Third color is blue, which is third digit, that's 6. So this represents a number 276. While the last color code, the last color band, is always a multiplier. In this case it's a black, that means it's 1. So it's 276 into 1. That's the value of the resistance in ohm. So always remember, this is first code, this is first digit number, this is second digit number, this is third digit number, this is a multiplier. In 5-band color code, if you see, the 4 bands are at one side while this last band is at the other side. So in this case too, first 3 bands represents first 3 digit, while the last band represents the multiplier. So in this example, for 6-band color code, we came up with a number 276 multiplied by multiplier 1. So it's 276 ohm. Last 2 bands, which is brown and orange and brown, I think. So this band, oh sorry, this is a gold and this is brown. This band represents the tolerance in percentage. So if you see, if we track this golden plus minus 5%, that means 276 ohm plus minus 5% in that value. This is the value of that resistance or resistor, which will be 276 ohm, which can be plus minus 5%. Approximately 10% of 276 is 27, so 5% is around 13 ohms. So it's 276 plus 13 ohm, 276 minus 13 ohm. So the value of that resistor will be in between these two values, which is 289 to 63 ohms. That's what it's saying. The value of that resistor is between these three values, these two values. So the question is, what is this last band, right? So this last band is a brown, which talks about the temperature coefficient. As you can see, this band is not present in these two resistors because this band is not mandatory, it's not always there. And this band is temperature coefficient, which is expressed in 1000 parts per million. Okay, so the same example is shown here. You can see the first digit is blue, first digit is blue, second digit is red, while third is a multiplier, which is a last band grouped together, it's a multiplier. Then there is a tolerance, which is there is only one band present, which is a tolerance, which is can be brown or red. So that's how you calculate the values of the resistor. This is a method to calculate the value of the resistance of a resistor. So to remember this color code, there is a quick way to remember that. There is this one sentence which is quite famous, so that you can remember the value of the resistor codes, which says that bad boy rape our young girl, but Violetta give willingly. So if you concentrate on the first alphabet of each word, boy, rape our young girl, but Violet give willingly. So each alphabet represents one color: black, brown, red, orange, yellow, green, blue, violet, gray, and white. So that's how each color is defined, and this is a way of remembering it. It's not hard enough, I think, to remember this, but again, this is not mandatory that you should remember this. There can be fluke meters, there can be other electronic instruments you can use, but this is a good method to know that okay, there is a way we can know the value of the resistor while just looking at the color bands. Again, this is explaining the same thing: first digit, second digit, multiplier, and tolerance. Although all is black, it's a black and white image, I think that's why it's black. Here you can see all the colors. It's a tolerance, multiplier, second digit, and first digit. Here again a 5-band code. So here we are going to talk in a brief about resistor construction. If you see carefully, this is a cross-sectional view of a resistor. The resistors we just saw in our last slide, how they look. Well, this is their very crude cross section. Here you can see the two connecting leads, lead 1, lead 2. These leads are used to connect the resistors into the external circuit. Then there is this insulating material which is always surrounded by an insulating material, so that there won't be any shorts when this material is get connected into the PCB onto the circuit board. Then there is a carbon mixture inside which defines the value of the resistor. So like I said, resistor can be made up of carbon films. Most of the resistors are made up of carbon films. They can be composed of metal films. So these are the most widely used materials used to make the resistors. Like I told you, these are the leads made up of can be made up of electrical connecting lugs. Again, this is a different kind of a resistor where you see a resistive metal wire. So the inside of this resistor is made up of a metal wire, not carbon mixture. There is a mounting feet here, cooling fins, because resistor heat dissipates lot of heat. That's why there is a cooling fins which helps resistor to get cooled down. That's it about the construction of the resistor. This is just to give you an overview of the construction. It's not recommended that you by heart this or you need to remember this. Just make sure that you know the resistance is made up of carbon, or it can be a metal wire. These are the two most widely used resistive materials. In this last section, we are going to see different types of resistors. I have found this chart online about the resistors and their types, and there are so many varieties in that. So first is this resistor which we saw. It's a lead. There are color bands, there is a carbon inside, this is an insulating material. This resistor is divided into two parts: a linear resistor and non-linear resistance. Now what we mean by that? Linear resistor has always a linear relationship between voltage and current. So it follows V is equal to IR, it follows the Ohm's law. While non-linear resistance doesn't need to follow this, because in non-linear resistance, the resistance, which is R, is defined by some other way. Like thermistor, resistance of a thermistor depends upon the temperature. Photoresistor resistance depends upon the photons, that means light. Surface mount resistors are very small unique resistors for the integrated circuits. Then linear resistors is a fixed resistor, which is a lead material, carbon material we just saw. Then there is a variable resistor whose value can be varied, this is also known as potentiometer. They are even widely used in the industry. For the potentiometer, there is a range of the resistance which we can vary. So you can see potentiometer, rheostats, trimmers. Rheostats are very big, they are bulky elements. They can be used in various industrial labs. You can see this is then fixed resistor has again carbon composition resistor, wire wound, thick film, thin film resistors, again carbon film, metal oxide resistors, fusible resistor, maybe this carries a lot of power. Then here if you look carefully, this is a power resistor. It has generally a power rating. If you see, this is like 10 watts. it can deposit a 10 watt, but if you use a normal resistor like carbon metal film resistor for 10 watt, it will melt down because it doesn't have that much capability to carry that much power. That's why you need a power resistor. These are used in lot of power applications, switching applications, so that resistor won't melt, it won't melt the circuit. This is again adjustable resistor. There are so many varieties in that. These are special purpose resistors, not much used, but you can manufacture them as per your requirements. Again, here you can see the leaded resistor. Surface mount resistors used for integrated circuits, commonly known as ICs. High voltage resistors, maybe high power resistors, they have capability of withholding high voltages. High power resistors are these we just talked about. So these are different types of resistors used as per the requirements in the industry. So my idea behind this lecture is to give you an overview of resistors, how they are used, where they have used, some of their applications. Okay, we learn about this resistor but we don't know the application, then that doesn't make any sense. So I thought let's give you a quick tour about that. I think here I will conclude this lecture and the resistor section. Maybe in the next lecture I'm going to talk about voltage sources and current sources, as well as voltage divider circuit. Maybe I will start with voltage divider circuit and then we will go for voltage and current source.